Review of complex numbers. Complex numbers are numbers of the form z is equal to x plus yi, where x and y are real numbers and I square is equal to -1. The modulus or the magnitude of the complex number z is equal to x plus yi is z is equal to square root of x squared plus y squared. That's the distance from the origin. Z is the distance from the origin to the point xy. A conjugate of a complex number is z is equal to x plus y is the z dash with dash on top, x minus yi. Polar form of a complex number z equal to x plus yi is z is equal r times cos theta plus I sine theta. And now we have example. Write the complex number in a rectangular form. So we perform this. We need to find cos 150 degree. This is polar form, and we need to write the rectangular form. So 150 degree, we can draw it. Here is 90, 180, so a little bit less. This is 150. How much less we are? 30 degree is my reference angle. Theta reference is 30 degree. Then we add sugar to coffee. So sine, cosine, or any trigonometric function is equal to the same function of a reference angle up to the sine where it belongs. So in this quadrant is my 150 degree, on the sine is positive. So cos 150 degree is equal to minus cos of the reference angle, because in this quadrant cosine is negative. So my number is equal to 2 times minus cos of 30 degree plus I. Sine is positive, so it's sine 30 degree. Now I need to use the chart. My chart says that cosine 30 degree is root 3 over 2. 2 times minus root 3 over 2 plus I. Sine 30 degree is 1/2, so I can write 1/2 I. Then we can distribute the 2. So this is 2 times minus root 3 over 2 plus 2 times 1/2 I. And we can reduce the 2. 2 is like over 1. So this is equal to square root of 3 plus 1i, or just I. Write the number. Example 1b. Write the complex number in polar form. Express the argument in degrees. So for polar form is z is equal to r cos theta plus I sine theta. So I need to find r and I need to find theta. So we can graph this. We can graph it. This is my x, this is my y coordinate, so it's 6 and somewhere -6. Here is my point. If I connect with the origin, I need to find this angle. But we can connect, we can use the right triangle, what we have right here, that right triangle, and find this reference angle. So this distance is 6 and this distance is 6. If we go by distance, not -6, that's the coordinate. So using Pythagorean theorem, r squared is 6 squared plus 6 squared. So r squared is 36 plus 36. So my r squared, I'm gonna write that this is 36 times 2 times. Then I take square root. 36 times 2, so this is square root of 36 times square root of 2. So my r is 6 root 2. Now my theta reference regarding this triangle, this is opposite adjacent, tangent is 6 over 6, which is 1. So theta reference, one, we need to get this from the chart. So my chart says that tangent is 1 for pi over 4, or in degrees 45 degree. But my angle, this is my reference angle, so my whole angle is 360 full rotation, less than 45 degree. So my theta is equal to 360 minus 45 degree. 360 minus 45 gives me 315. So the polar form of my complex number is z is equal to, we had r is 6 root 2 times cos of my angle 315 plus I sine 315. Now we need to, we have example 2. Find z times w, where z is equal to cos pi over 3 plus I sine pi over 3, and w is equal to 2 times cos pi over 4 plus I sine pi over 4. We need to recall the product and quotient formulae. z1 times z2, we multiply r's, and we have add the thetas, theta 1, theta 2, and when we divide r's, and we subtract theta. This is the product and the quotient from the theorem. So for my case, we need to find the product. So we have that z times w, we multiply r's. Here there's no r, that means it's 1 times 2, and then we have cos, we add the angles theta pi over 3 plus pi over 4 plus I sine pi over 3 plus pi over 4. Then we need to find common denominator. 3 and 4 common denominator is 12. So the first one we need to multiply times 4 times 4. This one times 3 times 3. The same story times 4 times 4 times 3 and 3. So we have that the product z times w is 1 times 2 is 2. Then we have cos. On the top I have 4 plus 3 is 7 pi over 12 plus I sine 7 pi over 12. And now we need to find the quotient z divided by w. We divide the r's, so 1 over 2, and we subtract the angle. Pi over 3 minus pi over 4 plus I sine pi over 3 minus pi over 4. Common denominator, 3 and 4 is 12, so this times 4 times 4, this one times 3 times 3, the same story here, times 4 times 3 times 3. Right, so we have that z over w is equal to 1/2, and then we have cos, and 4 minus 3 is 1, or pi over 12, plus I sine 4 minus 3 is 1, which is pi over 12. Example 3, write each expression in the standard form. We have 5 cos 75 plus I sine 75, all to the power 2. So we need to recall what does it mean, the power, exponent, exponent. So we have to the power 2, that's my form. So we're gonna raise r to the power of what we need, and then we multiply the angle n, which is just my 2 times I sine 2. So complex number in the polar form to the power n, we multiply the r times n, and then we raise r to the power n, and then we multiply the angle n times. So in my case, this is equal to 5 to the power 2 times cos 2 times 75 plus I sine 2 times 75. So this is equal to 5 to the power 2 is 25 times cos 150 degree plus I sine 150 degree. As before, we need to find the angle 150 degree. So here is 180, 150 right here. The reference angle is 30 degree. So we have add sugar to coffee. On the sign is positive in this form. So we have 25, cos is negative, so minus cos of the reference angle is 30 degree, plus I sine is positive, sine 30 degree. Then we need to use our chart. Cosine 30 degree is root 3 over 2. So we have 25 minus root 3 over 2 plus sine 30 degree is 1/2, and I will put the I at the end. And now we need to distribute the 25. So this is like over 1. So this is equal to negative 25 root 3 over 2, and then we have plus 25 over 2i.